Hello friends, this is Durga from IT Varsity, a one-stop shop to learn all the technologies. I hope you guys can see my screen. And today we will be talking about, we will be continuing about the Scala and Spark workshop, which is started last week and which is paused due to family emergency. So we'll be continuing where we have stopped. Let me check that. Okay, 1 minute, okay. I need to set up the environment. It will take a few minutes to set up. And this is 4-hour session. So we'll start in a moment. Give me a moment, okay? I'm validating that you guys can hear me. Yeah, so you guys can hear me. So to bring you up to the speed, this Scala and Spark workshop is started last week. And due to some family emergency, I have to stop in the middle. And it's primarily for live audience. I'm streaming it to YouTube so that they have this for backup. So to learn from these videos, you don't need to pay anything to me. But if you want to practice, I will highly recommend you to go to labs.itversity.com if you don't have proper environment to practice. And check the plans. We have plans of $14.95 for 31 days, $34.95 for 93 days, and $54.95 for 185 days. You can sign up with one of these plans and you can start practicing. Okay, so as I have mentioned to you earlier, this is the streaming of the live session which is going on through WebEx as well as the classroom. So let me start the WebEx session and then we'll take it from there. So I'm starting the WebEx session. And I'm sharing my screen. Okay, so folks on WebEx, I hope you guys can see my screen and also you can listen to me. Please confirm in the chat. Okay, thank you, Vicky. So let's get started. So what we have done last week, we started with Scala. We learned basics of Scala. And then we started with Spark. And we actually started developing the Spark program using IntelliJ. And I have developed it along with me. People who attended the last week sessions, they also have developed it. And towards the end of the session, we have compiled the jar file of it. And now we want to ship the jar file to the cluster, and we will see how we can run it on the cluster. Okay, so let me open the project. It is called as S&S, Scala and Spark workshop. So I'm opening that. Yeah. Let me. It's the same link which I have. Yeah. Let me. It's not working. Okay. Okay. Copy meeting URL and then. So that is the WebEx link. Okay, so now let us get started. Let us continue where we have stopped. So this is the program which is developed. We started with defining the dependencies. This program requires two packages. One is Spark core packages to develop the Spark program, and the other one is type-safe config, so that we can externalize some of the parameters, in this case execution mode. And then if you go to this program called the wc.scala and choose the object or class of type object, and if you look at the code, first thing what we have done, we have used type-safe config factory.load method to load the properties which are defined in application.properties. So here we have defined one property for development and one property for production, because I want to run it in local mode on my PC and I want to run in yard mode on the cluster. Okay. Then once it is loaded, using props.getConfig, one of the first parameter is about the environment. Using that information, we are getting the execution mode. So when we try to run this locally, it will with dev as first parameter, it will run in local mode. And then this is the logic to perform the word count, where we are reading the file and then applying the flat map to tokenize each line and divide into multiple words. And then we are creating tuple for each word with key as the word and one as the value. And then we have used an aggregation function called ReduceByKey to add those values. And in the end, I want to print the word as well as count of it by delimiting with the tab. That's why I'm using map function. And then finally, I'm actually saving it as text file to the output path. Okay, so input path and output path are passed as arguments. And execution mode, using the first argument, we are reading the properties file, properties on the properties file, and we are determining which mode the application should run. And then once this is developed, what we have done, so you can get the location of this project from here. You can right click on this and then say copy path and go to that path. Okay, and then you can say sbt package. When we run sbt package, it will create jar file out of it. Okay, so this is the location of the jar file, and if you understand the naming convention for the jar file, this is my application name. How it is determined when we create the project, that is the name I have given. And then this is the Scala version using which I'm developing the applications, and this is the application version. Okay, and if you go to build.sbt here, you can see the name, version, and Scala version. So using this information, it picks the name underscore the major version of Scala, which is 2.10, then hyphen and the version of this program which is defined as part of build.sbt. So using this convention, it will create the jar file. So I have set up Spark separately along with IntelliJ. Using that Spark also, I can validate this program. Okay, so as I have Spark already on my PC, I can actually run Spark submit here as well. So Spark submit first takes, to break into multiple lines, we have to use backslash. This is the Linux or Unix notation. And first thing what we have to pass is class, and the class name is this one. Okay, word count. It's not part of any package, so we just have to give the class name like this. Okay, once you give the class name, if you want to add additional parameters, you can specify this those things here. The examples could be the memory configuration, course configuration. If you want to plug in the third-party jar files, all those things can be added using different control arguments. These are all called as control arguments. But for our purpose, we don't need to use all these things. After giving the class, Then we have to give the jar file name. Our jar file name is this one. I am using complete path. You can give relative path also. Okay. Once you give the jar file name, you have to pass the arguments. The first argument is whether you want to run it in dev mode or production mode. I want to run it in dev mode because this is local. There is no yarn configured on this cluster. So I'm passing dev as the first parameter. And then the input path, which is users IT varsity research data code count.txt, and the output path, which is the third argument, I would like to give WC. So here we have to give the non-existing directory. So there is no directory by name WC. I'm using that one here. Okay. It will create the directory WC and it will save the output to there, and then hit enter. Okay, now it is running. While it is running, it will give you an URL, and you can use that URL and try to check the status. But this is a small program. It will not sustain for a very long time. Once the program is done, you will not be able to view the details. So there should be a link. It should give some link somewhere. Yeah, this is the link. But as of now, the program is already executed and it came out. Hence, you will not see much of action. Okay, so let me type this, and it failed because it is already done. The web service will be killed once the program is executed. When we actually run on the cluster, it will be copied to job history server, and from there we can pick it up. But in local mode, you will not be able to see. Okay, this is how you can validate on your PC itself if you have Spark setup. If Spark is not set up, you will not be able to test. So I will give 10 minutes time here. You first make sure that you have Spark configured, installed, and you should set environment variables. I have covered those things as part of the last session. Here you just have to say Spark shell or Spark submit and type enter. And if you are getting the feedback, that means Spark is set up and configured on your PC, and you can test it out. So first thing what you have to do, if the program is developed and tested on IntelliJ, you copy the path from here, copy path, go to the command prompt, give the path or paste the path, and then run fpt package. It will create the jar file, and then use the Spark submit command. Like this. I'm giving an example. I will be pasting in the chart. You can try this one. You have to make necessary adjustments as per your PC, and then you should be able to test it. Okay. So I will give 10 minutes time. You can give a try, and if you run into any issues, I will troubleshoot and I will try to resolve those issues. And then we will copy this jar file to the cluster, and we will run it on the cluster, and then we will actually go to the execution lifecycle of the entire job. Let me paste it in the YouTube live also. And also I will update the gist so that you guys have it for your reference. Okay, let me update this one. Okay, I'm also pasting the Spark submit command here. So that you have it for reference. Okay. And this is the gist link for your reference. Also, I'm pasting it in the description here. So those whoever is watching this YouTube live session, you should go to the description and you should be able to get the link to the GitHub code, gist code. Okay. So have you guys tried it? I will give. Okay, wiki is done. What about others? If you are new to this, I cannot wait until you guys are done. But if you are following me from the last week, and if you are stuck in the middle, let me know. I will be troubleshooting the issue, and then we will take it from there. Okay, that means your jar file, the class name is not correct. So whenever you run into this class not found exception, first thing you need to do is run jar tf command and then target, go give that path of the jar file, which is target scala -2.10 and then snd. This is the jar file name. And you can see there is a word count dot class here. This is what you need to give. You should not give the program name. Whatever class name you are trying to invoke, you have to give the class name. Then you will not the package properly.
when the project folder.
Yeah.
Good package.
They are not like run find dot create hyphen space double quote star. Okay. If you want, you should never give your input path and output path in the package and Scala folder. So these are the programs. Which one is the work on program? Scala. Jar period, target, scanner, and then the program. Not building the package properly. Right, understand as well. Okay, that will be your everything.
This one is doing also file. The file, the class you can do it.
Just for the two everything package and do the one activity package already. The activity package.
This man class is prepared.
That is fine. That is fine. You can say activity clean. And delete this directory. You work on file, you work on directory. That is okay. I don't have to know. The directory is fine. And then you can implement some of the remove double check. Remove everything, remove the yeah. Got to put in that. Start class. Backslash icon, backslash icon. Immediately, escape, again backslash icon. If it has, mali rm, no code you can tell. So run activity package. Now run Java on the Java. outside.
So you should have those folders again.
You should not put it in this. This is
Okay.
one level folder.
So you can
Data
have
should be somewhere else. You can give it file data. Now you can shift the jar file to the cluster.
Okay, some people try actually keep the data folders also within the project. Okay, this directory in my case S&S is primarily for the application. We should not have data in this. That's why I have created a separate directory for data, which is users ITversity research data, and then now you see my output directory is here, which is WC. And if I go here and then if I run lsltr, it lists the files, and then I'm running cat command to get the output. Okay, so now we have validated from the command prompt also. Our jar is in working condition. Now we can ship this jar file to the cluster, and then we will try to run on the cluster on a much larger file. First, I will try to run on the cluster, and I will explain the life cycle of the execution, and then I will give you some time for you to execute on the cluster. Okay, and don't run along with me because I will be running this on a 30 GB data set, and if everyone try to do that, it will take a very long time, and we will be wasting time unnecessarily. So first, let me run it on the 30 GB file, and then I will give you the. I will show you an example where you can run it on 1 GB or 2 GB dataset. So each of you can run simultaneously on 1 GB or 2 GB dataset. Yeah, I'm showing that how to execute on the big data labs. And this you can do. Those who are on YouTube live session, YouTube live, whatever I'm showing now, you can only do it if you have access to the lab or if you have access to your own environment. Okay. So here, first thing you have to do is do SCP. If you are using Windows, if you have Cygwin, you can use Cygwin to copy the files using command like me with SCP, or you need to have tools like WinSCP. And if you have WinSCP, you have to use gw01.itversity.com as host. Okay, and port number is 22. So host name is gw01.itversity.com. And then you have to give the credentials to use WinSCP for the remote server to which you have to copy the files. So you can go to the labs.itversity.com. I think already I have one here. I'll be using that. Okay. You have to log in. Once you log in, you will get the username and password from here. So wherever it asks for the username in WinSCP, you have to give the username. Wherever it asks for the password, you can copy this password and paste it over there, and then you will be able to see the remote Linux file system on the right side, and left side you will see the local file system. You can copy from local file system into the remote or remote to the local. In this case, you have to copy from local to remote. Okay, that being said, if you are using Cygwin or Linux terminal or Mac terminal, etc., you can directly use the SCP command. Okay, and here I am using relative path, which is target Scala, and then S&S blah 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 .jar file, and then my username, which is dgadraju at hostname. Okay, and I am trying to copy to home directory on the remote server. So this tilde represents the home directory on the remote server. If you want to give the full path, you can say like this: /home/your OS user ID. Don't use mine; it will not work. You have to give your user ID. Okay, or you can just say tilde. You can do either approach, and then run this command. Get the password from here. And the jar file is copied. If you are using terminal, then you can do the SSH. Or if you are using PuTTY, you have to log in through PuTTY. If you are using MobaXterm, you have to use MobaXterm. If you are using Sigwin, you can follow me and say SSH your username at the host name, which is this one, and then it will prompt for the password. Paste the password and hit enter. Okay. Now you are in the cluster, and the first thing you need to make sure is to confirm that you are in the right directory where the jar file is copied. So I copied to the home directory, and here is my jar file. Okay, I can do that. So cp s&s, and I'm copying it to temp location. Okay, so you can log on to the cluster, and then you can do cp/tmp s&s, and you can copy to your own directory like this once you log in. Okay, because it is in temp, everyone can access that jar file. Okay, and then from there you can run, but don't run along with me. First let me run, and then I will give you enough time for you to run by yourself and experience how it will run on the cluster. Okay, so the same command, so the way you can run the command is using Spark submit, the way I have done locally. And the first parameter has to be class, and the class name is word count. And then I want to run it in the yarn mode. When we run it in the yarn mode, if you don't specify this parameter called -- master yarn, even though in the program we have yarn client, when we pass the parameters broad, still it will not run in the yarn mode. To run in yarn mode, you have to say master yarn. In the program, you have configured to yarn client. So the program will be running in the client mode to the yarn. So it will be running under the scope of yarn. So you have to add this additional control argument called -- master yarn. Only then it will work. Okay. And then once you specify master yarn, now you can give the jar file name, which is this one. And it takes 3 parameters. The first parameter is the environment. You have to tell what command you are using, Madhav. Jar is there. If you paste your command, I will tell you if there is any issue with your command itself. Okay, and then the input path I'll be using is public random text writer. You can paste the command. I will confirm whether you are using the right command or not. Run pwd command, and then paste the output, and also you have to, and also people who are chatting on okay. Okay, let me see. Okay, let me log in with some other report. SSH root at gw01.university.com. Yeah, I don't know what the hell is running. So I'm logging in. I'm logging you as you only. What is your user ID, Madhav? Okay. So I'm logging in like you. Okay. And then whatever command you are running, I am So here you go. The first one is the jar file. Okay, there are some directories also with that name under temp, and it is giving more files. Okay, so I'm running like as you only. Okay, so now I'm exiting and logging in as mine. So this is the input path which I will be. So first parameter is I want to run it in the prod mode, so I'm giving it as prod, and this is the input path: public random text title, and then output path will be user D Gadiraju. Here you have to use this path only. Everyone have read-only permissions on this location to read data from this HDFS location. And then output path, you have to give your user space in HDFS. So slash user is the base directory, and then there will be a subdirectory with your OS username. If it is Madhav, it will be Karma Matters. If it is Abhishek, whatever OS user he have. So depending upon your user, you have to use the path here, and you have to give the non-existing directory here in HDFS. So I'm just giving word count 99 because I have been running this quite several times, so probably there could be some directory. So I'm just giving some unit directory with 99 at the end. Okay. So before running this, let me show what is there in this location. And if you run ls-ltr and try to look into that location, you might or you might not find anything over there. If you have local file system similar to that, you will see the output. If there is no local file system, you will not see anything. But here data is in HDFS. Okay, so we have to run Hadoop fs-ls and give the path and hit enter. And you can see the files that are available here. So when I actually ran it on my local machine earlier to validate, I have given the local file system. Here I'm giving HDFS file system. When I set up the cluster, I set up using Ambari. And when you use Ambari or Cloudera to set up the cluster, Spark, which is a distributed computing framework, and HDFS, which is a distributed file system, are integrated automatically. So when we do not specify any protocol, automatically it picks HDFS in the local files in the cluster. If it is local file, if you run on your local machine, by default it is integrated with local file system. So when you don't give the protocol, it uses the local file system. So here what you need to understand is, when you are running on the lab, if you don't specify the protocol, then it is HDFS path. Okay. If you want to access something on S3, you have to give S3. S3 is Amazon's file system. You have to give S3:// and then bucket name, few more things. You have to give the complete path from S3. If you are running on Azure Blob, you have to give WSB and so on and so forth. If you want to run it in local file system, run against local file system, which is not very usual on clusters. We don't try to run against local file system, but if you want, you can say file:// then you have to give the fully qualified path starting from /. So we'll see 3 slashes here. Now I didn't specify any path. So by default, what it will do is it will consider to be HDFS, and internally it will be like this. This is called as HDFS URI. Okay. So you can give the HDFS URI if you are interested, but even if you don't give, it will automatically pick it from the HDFS itself. And then this is the HDFS path. So whatever we are trying to read is from this location for the input. And even for output, it is like HDFS nn01.itvarsity.com :8020/user/dgadiraju/wordcount99. Yes, that's correct, Ram. OP also will be in HDFS. Okay, by default, if I do not give the protocol, it's HDFS. So HDFS is Hadoop distributed file system. Don't worry too much about it. Just understand that Spark submit multiple protocols. One is local file system with file : //. One is HDFS, which is default in the cluster, and the other ones are S3, WSB, etc. So depending upon the file system you are using, you need to understand how to pass the input path. You have to do the diligence at the time, and you have to start from there. Don't worry too much about HDFS or WSB or S3 here, even if you do not understand. Okay, because this is purely Scala and Spark workshop, and I don't want to get into HDFS in very detail. I will cover few important aspects as we proceed, but I don't want to get into too many details and dilute the intention behind the workshop. It is purely Scala and Spark workshop. If you want to know what is HDFS and all those things, you can go to ITversity YouTube channel and do some search on HDFS, and you will get ample amount of resources. Okay. So now, if you see, a few things which you need to understand is, I will cover few important aspects, and probably by the end of the today's session, you might understand what HDFS is. If you still have any questions, you should do your homework to dig into HDFS further and try to understand it. Okay. So here you can see there are 30 files in this location, and I'm giving that directory as the input path, not the file. Okay. And this directory have 30 files, and most of them start with part M, and it is approximately 1 GB worth of data. Okay, 1 GB plus few megabytes. Hence, we are trying to process 30 GB worth of data, which is in HDFS, to perform the word count. Unlike locally, we validated with few lines of data. Here, we are actually processing 30 GB data. Okay. So this is how the syntax has to be if you want to run it on the cluster. You have to specify --master as yarn. So let me do this. Okay, now it is running, and let me copy paste this command for your reference. Okay, there seems to be some error. Okay, okay, got it. Okay, I understand. So here path is not correct. Like this. Okay, and then public random text writer, and output is user port count 99. So let me copy this one before I start running this. Oh my god. Okay, it is. I think it is not responding. Just let's wait for. Yeah, now it is okay. It has become a little bit slow. Okay, let me close the. So let me copy this command. I will paste it in the chat after I start running this. Okay, and don't run. Okay, I will not paste this because it will try to process entire 30 GB worth of data. I will paste a little bit alternative to this once I validate. And now when it is running, to monitor, you have to go to something called Resource Manager UI. It runs on rm01.itversity.com column 8088. If you want to get the quick link, you can use this one. This is the quick link, which is available as part of the labs.itversity.com. Once you log in, you will see the link. You can go here, and this is the one which is running right now. Okay, so you can click on this, and then it will take you to the Spark job associated with the program that is being running. Okay, now let us understand the life cycle of this program, and then I will explain few important details about Yarn also. And also, as we proceed, we will try to understand few details about HDFS as well. So if you click on this job, so at a higher level, a program can be run as one job, one or more jobs. In this case, it's a simple word count program, and it is running only as one job. Typically, depending upon the number of actions you have as part of your program, there will be so many jobs. In this case, there is only one action, which is save as text file. Rest of the stuff, such as flat map, ReduceByKey, and map, are all transformations. The action is only save as text file. If you have multiple actions as part of the flow, it will typically result into multiple jobs. Because in this case, it has only one action, there is only one job associated with this program. And one job can run in multiple stages. Okay. In this case, the job is running in 2 stages, and as part of the first stage, this is called as DAG. Okay, and sc.text file is the API to read the files, and then flat map is the transformation to break down the line into words. Map is the transformation to create a tuple for each word. ReduceByKey is the transformation to aggregate. Map is the transformation to change the format of the output. Instead of tuple, we change it to tab delimited. And then save as text file is the action using which you are trying to save the file. Okay. So here, as part of stage 0, it read the data, and this is called as, this entire stuff is called as DAG, and only when the action is invoked, this DAG will be executed, and this is the execution flow. So when we execute the program, first it read the data using sc.text file API, created RDD out of it, and then apply these transformations over its life cycle, and finally it is saving as text file. And here you can see that as of now, still stage, the first stage, which is stage ID 0, is running, and you can see it is using 270 tasks to process the data. Okay, and what is the task and why 270, we will see a little bit later. If you click on the stage, it will give few more details, DAG for that stage, detailed DAG for that stage, and also it gives a lot more information about how the program is being executed. Okay, so from this page, you can see as of now it is still executing stage ID 0, and it requires 270 tasks to finish. And stage 0 is reading the files, applying the flat map, and applying the map on it. So if you click on this, it is giving more details about that. So it is saying from where we are trying to read the data. Okay, and then creating the RDD out of it, and which is being passed as input to flat map, and the flat map have done its whatever processing it is supposed to do, and then data is passed to the map. Okay, this is the flow. And if you scroll further down, you see the program is executed by 2 executors. Okay, why 2? I will explain a little bit later. But more importantly, we have 270 tasks processing this data. Okay, so in this case, each task, each executor will be processing 135 tasks. So once it is done, you will see 135 tasks processed by this executor and 135 tasks processed by this executor. Okay, and here it will give the details about each executed task. Okay, so we have 270 executed tasks which is supposed to execute. So by the time all the 270 tasks are completed, you will see all the details here. Okay, now let us understand why it is using 270. Now we are getting into few important concepts of HDFS. Okay, as I have mentioned to you, this public random writer is nothing but HDFS path. Okay, and there are 30 files in that, and each one around 1 GB plus few megabytes. Okay, so HDFS stands for distributed file system. So the main intention of HDFS is whatever you are seeing here is just logical. The name is, it's just a name. Physically, what it will do is it will break down this file into multiple blocks, and it will be stored as blocks physically on the cluster. Okay, that is how HDFS makes sure that data is distributed or files are distributed across the cluster. Now let us take example of one file. Okay, and if we can actually read the metadata by using a command called HDFS FSCK, view the path of that file. So I'm trying to read from that file, and then I can say files and blocks. Okay, and hit enter. If you see, the file is approximately 1 GB plus. So let me say Hadoop FS du -s -h. This will give the size of the file in readable format. Rather in bytes, it will give us in GB. You can see it's 1 GB plus few bytes or few kilobytes. Okay, so here it is saying that the file is, there's only one file with that name, and the file is divided into 9 blocks. Okay, and this is the block ID. What is this block ID? This block ID is nothing but the name of the file which physically stores the first 128 MB of the data within that 1 GB file. Okay, like that we have 9. So each one of these things are 128 MB, and the final one is the leftover, which is 28 MB. Okay, so this is approximately 1.03 GB file, and the last one is only 28 MB, but the rest of the stuff is 128 MB. And how it determines 128 MB? If you go to Ambari, okay, again, if you go to this and click on, and go to the quick links and click on Ambari, it will take you to the Ambari UI. You have to give your lab user ID and password to log in into the Ambari, and then you can click on HDFS. We are talking about HDFS. You can go to configs, and you can check the block size. And this DFS block size is nothing but 128 MB. And if you see this value and the size of each one of them is same except for the last one. Last one is only the leftover. Okay, so that block size actually determines how the file of 1 GB or more, means whatever the size of the file. If it is more than 128 MB, it will have more than one blocks depending upon the size, divided by 128 MB. In this case, it's 1.03 GB. If you divide it by 128 MB, it will be 128 blocks, and the leftover is the 9th one. So that's why we see 9 blocks. And like that, we have 30 files. So 30 into 9, 270. So using this number, it is using 270 tasks by default to process the data. Okay, so that is how the 270 number came into picture. And You can also check the stages just by clicking on the stage, and you can see still 175th task is being running out of 270. It will take some more time to process. Meanwhile, let me take this question. Yes, by default, you can overwrite those things and you can make necessary changes. And also, if you have any questions, Madhav, please respond to everyone so that people have the context, because people might not be able to see the chart when I'm reading. And if I forget to read out loud, then they might miss the context. So please respond to everyone going forward. By default, number of tasks is equal to number of blocks, but you can change it uh, as part of your program. For now, just ignore how to change it and all, and make sure you understand that this 270 comes from the number of blocks of the file in HDFS or the files in HDFS. What is that? That is so. Let me go one by one. Okay. So here you can see each task is approximately reading 128 MB, except for the last block. Whenever it hits the last block, the size will be lesser. And then if you look at the output, okay, it is showing 4.3 MB out of 128.1 MB input. This shuffled write size or records is nothing but the amount of data it is generating the output to the next stage. Okay. Okay, so let me give the path. So this is the path. So this is the URL. And also Wiki, if you go to the labs.itversity.com, if you log in, there are quick links here. You can click on the resource manager URL here, and then it will take you to something like this. Okay, and then you have to figure out which one is the one which you want to look into, and then click on this application master URL. Okay, and then it will show the jobs for the job. So one Spark submit can create multiple jobs depending upon the number of actions. In this case, we have only one action, hence we have only one job, and each job will have multiple stages. Okay, so typically flat map. So wherever we have to get the shuffled RDD, there a new stage will be created. So now if I go back here and I'm coming back to the base directory, and I'm running the program again one step after the other, because there are few things which you need to understand. BT console, which will launch Scala with all the Spark packages. Okay, and then if I say sc.text file as users / itversity research data word count.txt. Okay, import alt.fhc alt val conf equal to new Spark conf set app name word count set master total lsc equal to new Spark context conf. Now if I go back and run this, it is creating map partitions RDD. Okay, now I am running a flat map. rec.split. So I'm breaking each line into my multiple records by splitting using space, using flat map function. And this one also results in map partitions RDD. Now, after flat map, if I use map and then create tuple like this, this also create map partitions RDD. Okay, now if I apply the reduce by key, these are all transformations. That's why it is not executing. It is just creating the DAG internally. Okay. And then if I say underscore plus underscore, this is one way to add using reduce by key. Even now it will not execute. It will only create the DAG. And here the RDD is of type shuffled RDD. So wherever it creates the shuffled RDD, it will evolve into a different stage. So here if you see, out of this flow, text file created a RDD, flat map created a map partitions RDD, map created map partitions RDD, but reduce by key will create shuffled RDD. Hence, it created a new stage. After that, again, map, it will create map partitions RDD, and then we are saving into file. If you use another action, another transformation, which will result in a shuffled RDD, then you will see one more stage. Okay, so the stage is created by a special RDD called shuffled RDD. And what is shuffling, I will explain a little bit later. Now coming back to okay, the program is executed completely. Anyway, I will be so at a higher level, you can see as part of the stage one, our stage index ID is 0. It has read 30 GB worth of data, and the shuffled write is only 1 GB. Okay, so after doing the word count, while performing the word count, if there are multiple words as part of the output, it actually uses concept of combiner, which I will explain. And that due to that combiner, it is only generating the output of 1 GB. Okay, that is after reduce by key, or as part of the reduce by key. Even though reduce by key is showing as part of the stage one, some things will happen in the intermediate stage as part of the shuffling. So we will see that later. Anyway, the output of this map function, which is being passed to reduce by key after shuffling, is only 1 GB. And finally, that 1 GB is aggregated, and the final output is 900 MB. Okay, now if you click on this, and here we are talking about at each task level. So that is at the higher level across the job. Now we are talking at the task level. And as part of the task, you can see that this one actually processed 128 megabytes of data as part of stage 0. And then the output, which is passed to reduce by key to perform the final aggregation, is only 4.3 MB, and these are the number of records. Okay, we will see the shuffling in a moment. But for now, you should have understood how the 270 came into picture. And at a higher level, you might have understood the metrics. Now let me go back to executors. So there, by default, it uses 2 executors. Let us understand how the tasks, if you look into these numbers, there are 270 tasks as part of the stage 0 and 270 tasks as part of the stage 1. And if you click on this link, now after the execution is done, you can see that as part of the stage 0, one executor processed 138 tasks and the other executor processed 132 tasks. If you add together, it is exactly equal to 270. So the 270 tasks are distributed across these 2 executors. And then within each executor, the tasks will be executed. Okay, a task is nothing but a JVM, which will get the jar file and read its 128 megabytes of data or lesser if it is the last block, and apply the logic in the jar file on top of the data. Okay, so here those two executors have actually processed 270 tasks. And before getting into the shuffling stage and understanding that, let us understand the number of tasks on the second stage. On the second stage also, there are 270 tasks. How it determined? It purely determined on the same aspect. But most of the times, it actually it is actually a incorrect value. You should not use um, you should not leave it to the default, because as part of the stage 0, there are 270 tasks to process 30 GB of data. But as part of stage 1, it has to only process 1 GB worth of data, and we are using 270 tasks, which is too much, which is not a good. We are allocating a lot more resources than it should get. For that reason, if you go to the syntax by going to Spark Programming Guide, if you go here and click on Spark Programming Guide and go to transformations and see the syntax of ReduceByKey, it has an optional parameter called numTasks. If we change this value, we can reduce the number of reducers that could be used. Okay, so let me change it here, and I will give only 8 reducers. Rather than the default 270. The 270 is determined by the size of it. So if you are doing a lot of filtering, if you think that at the reduced stage, the amount of data that needs to be processed is very less, depending upon the nature of the work, you have to do the due diligence and you have to tell how many tasks it should use to execute. In this case, as it is approximately processing 1 GB worth of data after the aggregation, I'm giving 8 tasks here. Now let me compile it. So whenever you make the changes, you have to compile it, you have to FCP, and you have to run it again. Okay. So while running this time, it will be faster. I will also teach you how to tune the performance. Okay. And before getting into that, let's start using Ambari to understand the load on the cluster. So this is the time when I actually ran the word count program. And if you see, hardly it used any resources. Okay, the cluster, this is CPU load. The CPU is not much. It did not use much of CPU. Now we will run it again with by tweaking some of the control arguments, and we will see the behavior, change in the behavior, and also we will get into a few more details in the execution lifecycle. Okay, now I am running SCP again. Need to get the password. Okay, file name is not correct. Okay, now it is copied, and fetch. I'm copying this one also to the temp. Okay, so that you have the latest logic. And now if I run Spark submit, yeah, this is the one. Okay, now will copy this to Sublime Text. Okay, here instead of I will remove this also so that it does not take a lot of real estate. Okay, and now on top of this program name and master, I would like to add one more parameter called num executors. Okay, and I want to give 16 or 18 executors, or let's say 32 executors. Okay, so and now we will see the behavior. We have made two changes. One, number of tasks on reduce is changed to 8, and then we are also increasing the number of executors. By default, it have used 2. Why 2? If you go to Ambari again and click on Spark here and go to configs and then go to Spark defaults. No, not Spark default. I think it's Spark env.sh. Yeah, this is the one. If you see here, you see Spark executor instances is 2, Spark executor cores is 1, Spark executor memory is 1 GB. So number of executors is 2 on each node. Sorry, by default, when you run the Spark submit command, it uses 2 executors, and for each executor, it is assigning 1 core and 1 GB memory. Okay, so as it is using only 1 GB memory with 1 core, it is only running 1 task within executor. So the reason why it is very slow is all the 135 or 138 tasks which was executed by the first executor out of the 2 executors. It is running in serial mode. It is not actually running in distributed mode. That's why your CPU usage is very low, and it took almost 20 minutes to complete the last run. Now we have increased the number of executors. So instead of 2, so each executor can run only one task. So at a given point in time, it was running only 2 tasks in parallel. Rest of them are in queue. Okay, now we are increasing it to 32. Okay, so what is it?
Number of cores.
Number of cores, that's a different concept. I will explain a little bit later. Within same executor, if you want to increase number of threads, you can add number of cores also. Anyway, num executors is more important, and hit enter. So it is taking a little bit more time to initialize because we have given a lot more resources to the job. Earlier, the initialization was fast because it was using only 2 executors. Now it needs to get 32 executors. Okay. Hadoop FS, because the directory already exists, it is failing. Hadoop FS. Okay, so let me copy this now and run this. So now if you look at the Ambari, go to the dashboard. Still it's in the initialization stage, so you will not see much action here. Now you see here 32 tasks are being running in parallel out of this 270. Earlier it was only 2. Okay, and you can see yarn memory is almost saturated. CPU also you will see in a moment. It will be there will be a spike in the CPU also. So we are using resources a lot more efficiently by increasing number of executors uh, to start this job. So to begin with, it will be a little bit slow, but after that, it will be much faster. See here, now it is moving like a lot faster. Okay. And also we can go to the resource manager UI. CPU cluster load will be high. I don't know why it is not coming up. We should see a spike. I think it is not getting the metrics. It will take some time, I think, to get reported. Okay, now you see. Click on this application master. You can see already 102 are done, and you can see instead of 540, it's now 278. 270 for stage 0 and 8 for stage 1. And if you click on this, you can see 270 for stage 0 and 8 for stage 1. Okay, and if you click on this, now the summary will show a lot more executors, 32 of them, 1 to 32. Okay, and then the number of executed tasks will remain same. Only by giving executors, only we are saying is use more parallelism to process the data. Okay, there is a way to reduce the number of tasks also, which I will cover a little bit later. But I am surprised that it is not showing a spike in cluster load. Yeah, this is the right one. If you go to yarn and if you see the CPU utilization, it's much higher now. Okay, I think the cluster load is a little bit different. No. So when it comes to CPU, if it is memory, it will start throwing out of memory issues. When it is CPU, your process will be going context switching between sleep and active mode. So your performance of the job will be lesser. So you have to be careful when you give the number of executors. It should not be too high, and it should not get your CPU beyond 100%. Okay, so now I hope you guys have understood what is happening in stage 0, what is happening in stage 1, why there are 270, and why it was running with 2 executors earlier, why it is running with more executors, why there is a significant difference in the execution time compared to the default and with 32. I hope those things are clear. Now we'll get into the shuffle part of this job. It is already done. It is completed by now, which is only hardly 2 minutes to complete the overall process. So what is happening as part of this shuffle? Okay, so there are multiple things which will control the behavior of this shuffle. The first thing is the key. What is the key? Whatever is the output in the output of the map, whatever is the first portion of the map, if it is a tuple, that is key. So in this case, our word is key. Okay, there is a question from Vicky. Yeah, so Vicky, this 270 is driven by the number of blocks in HDFS by default, because we are crossing 30 GB worth of data, and our block size is 128 MB. Approximately, there are 9 blocks for each file, and there are 30 files like that. So it has 270 blocks, and from that 270 number, this stage 0 is using 270 tasks. Okay. If it is map reduce, we use combined file input format if we want to, or not combined file input format, sorry. We'll play with the split size to increase or decrease the number of map tasks to process the data. When it comes to Spark, there is a concept of coalescing if you want to reduce the number of tasks to process the data. And that is again a code change. And we don't use it typically. There are scenarios where we have to use coalesce. Anyway, that is out of context a little bit now. I will talk about it later. But this 270 number is based on the number of blocks of the underlying files which we are trying to process the data. Okay. So now I am talking about the shuffle. So as part of the map output, what we are getting each word and a value 1. Okay, if you go to the program here, so this is the map logic. The input of the output of flat map is ported as input to map. Flat map, if there are 100 words in the file, flat map will create 100 records, and those 100 records will be passed as input to the map function, and there will be 100 word comma 1 tuples as output for the map. Okay, so the key, when we use ReduceByKey, we are saying by key, right? The key is nothing but the first part of the tuple which is generated as map output. Holding that key, we want to do some aggregations, and when it comes to shuffling, that key is the one of the major building block. And the second major building block is the number of tasks which either we pass as parameter to the function ReduceByKey or any byKey function, or the default. The default will be number of blocks of the underlying file system. It was 270, now it was 8. So this second important aspect of shuffling is that value, which is nothing but number of tasks to process this stage. In this case, it's 8. So it takes the key and take this 8, and if it is what it will do is it will apply the hash function on these words, and that hash function is nothing but integer. Okay, so each word will generate some integer value, and then always if you give the same word 100 times, hash function will generate same integer value. Okay, and then using that integer value, it will apply the mod function, and the denominator using which we apply the mod function is nothing but number of tasks which will be processing this second stage, which is 8 in this case. So for each integer value which is generated because of the hash function on the word, it will apply the mod function with this value, and depending upon the remainder, it will partition the data. Okay, in this case, the entire data will be divided into 8 partitions. And also as part of that partitioning, if there are out of 100, if 10 words is same, for example, if there is a word called the, and if it is repeated 20 times out of the 100, all the comma ones will not only partitioned but also will be grouped. So this partitioning and grouping using the keys and the hash mod function using the number of tasks, and then dividing the and then partitioning and grouping is called as shuffling. Okay, so when we see shuffled RDD as output, that means it is nothing but partitioning and grouping of the keys based on the hash mod value. Is it clear? Is it clear to everyone online? Now we have to get into the logic of combiner. Okay. Now let us understand why when the input is 30 GB, output is only 1 GB. Because there are so many unique words, but still there is only 1 GB of data. So George is asking a question, do we have control on the number of partition and how can we limit it? Yes. So number of partitions, this is the one which will determine. And we have to do our due diligence to make sure that the data within those partitions are evenly distributed. Okay, if we use 270, that means we will be processing 2/70th of 1 GB of data, which is not very efficient. Okay, hence we changed it to 8. So almost all the ByKey functions, if you go to the documentation, almost all the ByKey functions which will generate shuffled RDD take this parameter called num tasks. ReduceByKey, aggregate-ByKey, sort-ByKey, join, okay, co-group, and also GroupByKey, and also distinct. Okay, so this is the one which will actually control the number of partitions. We can even customize, but it is a very advanced concept which is out of the scope. We can also customize the logic of partitioning the data. Sometimes there could be significant skew based on certain keys in real world scenarios. At that time, we might have to use custom partitioner. And for that, there is a function called repartition and sort within partitions. And it takes the partitioner as the parameter. Here you can define the custom partitioner, and you can actually customize the partitioning logic also. By default, it's hash model algorithm. Okay. So Jaj is asking one more question. So everyone, please ask it to everyone. Change under send to change it to everyone and ask the question to everyone. So I can see there is a repartition in API. How is different from this? So repartition is not primarily to customize the partitioning logic. You can change the number of partitions at any point in time for the given RDD. Okay, it is different. So for example, let's say you started with 270 tasks, and then there are so many downstream processing which you need to do, and you don't want to customize for each and every partition. Rather, you want to use one single value for all the subsequent partitions. Let's say 8. You want to use 8 for each and every downstream stage. In that scenario, you just say repartition, and data will be repartitioned into those many partitions. And going forward, it will always use 8 as partitions. If you want to be more specific at each stage, you have to override that numTasks parameter. Is it clear, Judge? Repartition is to apply the same number of tasks for all the stages after that step. You don't need to determine what is the number of tasks for each stage. It will use the same value for all the following steps. But if you want to customize at any step and change the number of tasks or number of partitions, you have to specify numTasks on the functions which will generate shuffled RDD. So it is more generic. Repartition is more generic, and this one is very specific to that function. Okay. Yeah. So Madhavi is asking here, total number of tasks become 270 plus 8, right? So the way you should visualize this, you should separate each stage. Okay, you should not mix up. And the total number of tasks for a job is, yes, 270 plus 8. But for stage 0, we have 270 tasks. For stage 1, we have 8 tasks. Okay, if there are subsequent things, depending upon the way we use, it might add more tasks to the overall job. But you should separate and view for each stage. Okay. So I hope you understand how why 270 here and how we have customized to lesser number of tasks, and also you understand the concept of shuffling. Now we need to understand the concept of combining. Okay. So for this, I will take a simple example. Let's say we have a deck of cards. Okay, and there are three people to count the card by suite. What is suite? A spade, heart, club, and diamond. All those four are suites. So we have a huge deck, and there are three people, and we want to get count by suite. Okay. So if we don't use combiner, uh, for example, whatever we are trying to do here, we can actually use group by key also. And I have explained the difference between group by key, reduce by key, and aggregate by key as part of the last class. Using group by key also, we can use we can compute the aggregated result. Okay, and let me demonstrate that. Okay, here I am launching Spark shell master yarn and conf spark dot ui dot port equal to 22313, and then num executors, let me give as 16. Right, let me give as 18 or 16 is enough. Okay, 16. I'm launching Spark shell. So first, let us understand the difference in implementation using group by key and the reduce by key, and also we will see how it will be different while executing the data. Then I will explain the concept of combiner and when it will be used, uh, and then you will understand the difference between group by key and reduce by key as well as aggregate by key. We'll take break at 11, approximately 10:55, and we will catch up at 11:05. We will take 10 minutes break, and after that we will continue till 1, and we'll take lunch break at 1. And once the lunch break is done, we'll catch up at 2, and that session will go to 6, go till 6. Okay. So now the Spark shell is launched, and I'm reading the data. sc dot text file slash public random text writer. Okay, and then val data flat. Let me just say words equal to data dot flat map. You can see that data type of this data is RDD, and each element is of type string because we are using text file as the function. Okay, and also let me say coalesce. I will explain this concept of coalesce also. 135 dot flat map. Okay, and as part of flat map, rect dot split. Okay, so I'm using coalesce and then I'm applying flat map. Coalesce also will create the map partitions RDD, but you will understand the impact a little bit later. So the data type does not change because of using the coalesce, it will be same. And then word tuples equal to words dot map underscore comma 1. Okay, so output will of the map function is tuple, and even word tuples is of type RDD, but the data type of each element is of type tuple, and first element of the tuple is string, which is word, and second element of the tuple is int, which is numeric value 1. And then words group by equal to, I'm saying word tuples dot group by key. Okay. So group by key does not take any parameter except for num tasks. So let us give the num tasks as 32. There is a reason why I'm giving 32 here. Okay. And you can see this is of type shuffled RDD. It's not regular RDD, but each element in that RDD is of type tuple. First element is the word, and second element is not typical integer. It's iterable, which means it's a collection or array. Okay. And as it is collection, we can use any collection, Scala-based collection functions and do whatever we want. In this case, this iterable will have all ones. Okay. And then using that, we can use any Scala-based API and get the count if we want to use GroupByKey. Okay. If you have to use ReduceByKey, automatically we are saying that implement some aggregation function. That's why first you have to give the aggregation function logic. So from the syntax perspective, this will be the difference. Words reduced by word tuples reduced by key. It means if you want to customize the number of partitions, here we have to give the, let me give it as total, comma value, plus total plus value. So this is the anonymous function for the first parameter to apply the aggregation logic. And then here I want to use 8 as number of partitions. Okay, from syntax perspective, after GroupByKey, you have to again do some additional logic to get the count. Whereas you have to invoke another function. What that function? So you can say words group by dot. Here for each input record, first we need to determine whether we have to use map or flat map. In this case, we have to use map because for this input record, you will get the word. So the number of keys for this group by RDD, for the number of elements in this group by will be equal to number of count of unique words. If there are 1 million unique words, there will be 1 million elements of type tuple. The first one will be the unique word, and the second one will be number of ones. It is repeated number of times in the file. Yeah, we can actually do words group by first and hit enter. See, now it is only showing 135, not 270. The reason why it is showing 135 is because of the coalesce. So meanwhile, no. It will actually use only, if I say coalesce 135, it will only use 135 tasks instead of 270. If I say 100, it will only use 100 tasks instead of 270. Default is equal to number of blocks. If you want to override, you can use coalesce and reduce the number of tasks to read and process the data as part of the first stage. Okay, and again, changing that value, you need to understand the side effects of this. So each task will be trying to process more amount of data now. And for each task, the memory is only 1 GB. So if you, out of this 30 GB data, If you just give 30 as part of coalesce, that means each task has to read 1 GB of data into memory and then process, and it will run into out of memory issues. So you need to understand the side effect of playing this with these parameters, and you should know what is the sweet spot before you start implementing as part of a particular Spark application. You should not just blindly increase and decrease. You should know the side effect of all these things. I will show in a moment. It is taking a little bit of time to get the first record. So meanwhile, Madhav is asking to explain shuffle again. So shuffle, what it will do is, so in this case, both GroupBy and ReduceBy has to go to the shuffle phase. Okay, there are mainly two building blocks of shuffle. One is the words or the key on which, so in this case, the key is nothing but the first element of the tuple, which is the output of the map function. And then the second building block for shuffling is, second important aspect for shuffling is the number of tasks. In this case, the number of tasks are 32. Okay, so using this key, it will compute the hash value, and then it will apply the mod function with this number of tasks which we are passing here. And then depending upon the hash mod 32, it will partition the data into 32 buckets, and the same word will always go to the one bucket. Okay. So that's how shuffling works. Shuffling is nothing but grouping and partitioning the data. Okay, it will partition the data by key, applying the hash mod function, and then if there are multiple words using the same key, then all those words, all those keys will be grouped together. So grouping and partitioning is called as shuffling. So Digambar Mishra is asking again, please change it to everyone and ask the question. He is asking, just wanted to thank you and your team for such wonderful videos. I watched the recordings and practice. Can we have a video for yarn architecture and how resource manager works? There are videos already on that. Let me see. So you can actually go through these videos. One is this one, running MapReduce applications using yarn. I don't have much on yarn with the Spark. I will create one video very soon. But you can go to these things. This one will give the difference between MRV1 and yarn plus MRV2. So you can just first try this URL, which will return all the videos with yarn in them from ITversity. And then if you have any questions, you can follow up. I will also create a video with respect to yarn and Spark. Okay. I only recommend official documentations. I typically don't refer anything else, so I'm not 100% sure about other good resources. Always you should get used to the documentation, because if there are any changes, they will document. Otherwise, you will always be behind of what is happening. So just get used to the documentation. That's the best place to follow anything. I don't read much of books, so I don't know. Anyway, so now when I actually do first, there is a word. So this is the word, and then it repeated twice. Hence we see 1, 1. Compact buffer is a special type of collection. When we try to print, it will say compact buffer, but it is nothing but iterable, which is collection. Okay. So now, if we want to, so if the data is like this, well, let's C equal to hello, and then array of 1, 1. This is how the data is. Okay. Now, if I want to add these two, what I have to do? I just have to say C dot underscore 2 will give this one. Okay, so that is how you can access the tuples. Underscore 1 will give hello, underscore 2 will give collection. These are all Scala concepts. And then I can say C dot underscore 2 dot size, which will give the, because it's only once, we can say size, and it will give the size of that array. If it is some other value, and if you want to add those things, you can say reduce underscore plus underscore. Okay, so if you want to add those things and get the and also you have sum, you can directly use sum also. Okay, so it's using these three approaches you can get. So in this case, if we are using group by key, we have to determine whether to use map or flat map. In this case, the input is like this, and output for each input record like this, I want to get the key, and the value need to be the sum of these values. So we have to use map function on it. So what we have to do, words group by dot map. Okay, and then I have to say rec implies rec dot underscore 1 will be the key, and then actually I can use mk string rec dot product iterator mk string rec dot underscore 1. No, I cannot use this one. I have to say rec dot underscore 1 plus, I want to print the results with the key, tab, and then the sum. And then I have to say rec dot underscore 2 dot sum. Okay, which will return integer. And I think I can use toString here. Okay, and let us see it will work. Yeah, it works. Now if I say save as text file, I'm giving the path user dgadiraju word count 98. Okay, so what I'm trying to do, let me reiterate the code. I read the data from this path, and then I have applied data coalesce flat map to split each line into multiple words, and then I have converted those into each word into, or each record into tuple, and then I have applied group by key with 32 partitions, and then I took the group by and then apply the map function, and as part of the map function, I'm getting the key and then tab, and then I am getting the sum of the array, and then converting it into string, and then I'm saving it to text file. Now hit enter, it will start executing. Okay, the reason why it is directly executing the second stage, because initially I ran this first command. At that time, it actually grouped the data already. Okay, that's why it is directly getting into the next stage. Now, if you go back to this and rm01.itverse.com 8088 is the port number. Once we are done with the group by, we will take 5 minutes break. We are almost there, and then we will do the reduce by key again, and we will try to understand the difference. Click on this application master, and here you see the number of tasks are 167. Okay, so this is the first one, the previous job where I have run the first command. Okay, this is the second job, and as part of this second job, it is reading the data and then it is proceeding further. But as the output is already executed as part of the previous job within the same session, it has cached that results, and using that result, it started the second one. Okay, you can see here stage 1 is showing as pending stages. It will never execute because these 135 are already executed. Okay, so I think it will be given as skipped once the program is executed. And if you click on this, okay, before getting into this, let's go back a little bit. I will run this again so that you don't get confused. If you go back this, let me do this. Let this finish. I will close this and I will run this again. Okay. Again, you have to change it to everyone so that everyone have the context. How to get this diagram? I'm not sure whether you might have joined late because I have explained quite a bit of times. The way you have to, there are multiple ways to go to that. Once you log into labs.itversity.com, there is a quick link section to this. There is resource manager here. You click on the resource manager and it will take you to the resource manager web interface. Okay. Once you go to the resource manager web interface, you should be able to determine which one you should access. I disabled the logging, that's why it is not giving the URL, otherwise it would have given the URL. Okay. By going through this, this is the username, and I'm running through Spark Shell, so I can determine that this is the one which I'm running right now. And click on this application master, and it will take you to the job UI for the Spark. Okay, so let this complete. Yeah, 1 minute. I'm killing this, and I'm launching again. So I will be running again from the beginning. Typically, if the logging is enabled, you will see the URL before Scala is launched. You can take that URL and you can paste it, and it will directly take you to the job. But as we have disabled, we have to go through resource manager. So first thing, I want to read the data. Once the data is read, I want to split the data. Okay, with coalesce and then flat map. And then I want to create the tuple using map function. And then I want to use group by. Okay, and then I want to run this to save. Okay, it is already existing. Let me give some other path. Okay, now it will run. So now if I go back to this one, okay, the previous one is also running. It is not killed. Okay, this is someone else. This is Atif. Okay, so he's running. I told not to run at this time. Let me finish, and then we will see. That's why it has become very slow. So let me kill this session. Atif, I'm killing this session. You can run it later. That's fine. There is no need to be sorry for that. Okay. So if you want to kill, I will give you some commands here using this opportunity. Not everyone can kill everyone's. As a super user, if you log in as root or yarn, you will not be able to log in as yarn. You can kill your session, but you cannot kill other sessions. So in this case, if you want to kill other session, administrators has to sudo to yarn, and then if you run yarn application list, it will give all the applications that are running at this time. So you can see two of them. One is from me, and the other one is from Atif. And I want to kill this one. So here I have to run sudo -u yarn, which means that I'm running this command called yarn application kill as user yarn. So this is telling that whatever command I'm running, run as user yarn. Okay, only administrators will be able to do this. Hello? Yes. Yes. I'm in the middle of the class. I'm in the middle of the class. You can give me a call at 1. You can call me tomorrow. Probably morning 9 o'clock. Yeah, that is fine. Yeah, bye. Sorry for the distraction. So this is how I can, the administrators can kill. Now it is killed. Okay. Anyway, now if you go to this application master, which is being running by me, and if you click on this, okay, now you can see there are 2 stages. And out of the first stage, so currently it is the first stage is active, and it is using 135 tasks, not 270, because of the coalesce. Okay, so probably, and if you click on this, and if you see the flow, first we are doing the coalesce, and then the output of the coalesce is being passed as input to map partitions, and so on and so forth. And if you see the input data which is being processed by this, okay, why it is processing 2.2 GB worth of data? That is not covered. Okay, these are executors, sorry. You should not look at the executors, you should look at the executor tasks. And you see each executor task is actually processing double the size of the data. Instead of 128 MB, it is now processing 256 MB of data. So it will still use those block boundaries. Okay, so in this case, this task have executed 2 blocks, and size is this one, and this is the number of records. Probably this one, it might be reading one full block and one partial block. That's why it is only showing as 155 MB. Okay, so this is how when you try to use coalesce, it will try to process a lot more data. And if you understand, each executor have resources allocated to it, and by default, the number of cores is 1, and more importantly, memory is 1 GB. Okay, so and these executor task uses those defaults. So executor task also will use 1 core and 1 GB because there is only 1 GB memory. You cannot go beyond certain value. What is that value depends upon the amount of processing you are doing. Sometimes even if it is 128 MB data which you are trying to process, if you are exploding the data, sometimes you might want to do some Cartesian products and all those things which can explode the data. And that data also has to fit in the memory. The input has to fit in the memory, output has to fit in the memory. And there are so many things which you need to consider. And also there will be overhead for your job execution itself. Okay, typically 1 GB to 128 MB or 256 MB will work for most of the times. Otherwise, either you have to increase the memory or you have to reduce the number of partitions you want to use as part of the coalesce. Okay, so you have to keep in mind that whatever input size you are trying to process and also the output which will be stored in memory, both together plus the overhead to execute the JVM, which is nothing but execute a task in this case, does not exceed that 1 GB of memory. If it exceeds that 1 GB, then you will start running into out of memory issues. Okay, that is the side effect of coalesce. Now we are seeing only 135 tasks instead of 270 because we have given coalesce as 135. And then one more thing you need to observe as part of this stage 0 itself is the amount of or the size of the output of each task. It is approximately 100 MB and we have 135 like that. Overall, it could be around, let us see the size. So the shuffle write is 10 GB. Earlier, it was only 1 GB. Now it is 10 GB. The difference is earlier we were using ReduceByKey function. Now we are using GroupByKey. Okay. As ReduceByKey use combiner concept of combiners, the amount of usage is very low. Okay. So the amount of shuffle write is very low. Here it does not use combiner, hence it is high. So now let us understand the combiner. Okay. So we will take a break here. We understood that GroupByKey does not use combiner, and also after the GroupByKey, whatever operation you want to perform, you have to apply that logic explicitly like this. Okay, whereas with ReduceByKey, it's a little bit different. We will reiterate ReduceByKey again once we talk about the combiner. Now the time is 11:14. We will start at 11:20. 6 minutes break, and we will take it from there. Okay, let it run. So before leaving, let me take this Digambar's question. If the worker node is busy or memory gets full, yeah, I mentioned to you that it will start running into out of memory issues. While determining the job itself, it will make sure that it chooses the appropriate worker node to process the data. And if it fails, for whatever reason, it will fail over to some other node. So fault tolerance is inbuilt as part of the yarn architecture. And here it is using yarn to process the data. So it will be automatically taken care for you. I hope Digambar have heard the answer. Anyway, now I will stop for 5 minutes. అంటే మీరు born and brought up in Mahbubnagar?
అమ్మమ్మ వాళ్ళది స్టేషన్ కనుక వరంగల్.
ఓకే, సో ప్యూర్ తెలంగాణ అన్నమాట.
తెలంగాణ పక్కా అలా ఏం లేదు, అది అలా స్ప్లిట్ చేశారు ఇక్కడ తెలంగాణ అని. సిటీకి వచ్చి 10 years 12 years అవుతుంది. 2004
ఓకే. So I'm back. So it seems it is failed. I think 32 is too low. Oh, container killed on request. I think someone have killed. Let me see. Okay. Anyway, it will be, I think, averred out. Yeah. Oh, it actually restarted the job. So I'm killing this. Okay. Don't know who killed it or what caused the issue. Probably we might be trying to process too much of data, and that could be the issue. Anyway, I hope you guys got that. GroupByKey actually, what it's doing is it is just tokenizing the data, and for each word it is actually shipping all the ones associated with it. Okay, it is like if you have a deck of cards and if there are 3 people, if you have 1 million deck or 4 people, if you distribute evenly for 4, each one will get 250,000 records. Okay, and if you want to do count by suite, using group by is like each individual only segregate the data out of the 250,000 records he got by the suite. So shuffling and sorting is that, so each individual get 250,000 cards which are randomly distributed. Each one he will have cards with all suites, right? Club, diamond, heart, and spade. Now, if each one get 250,000 random cards, as part of the shuffle and sort phase or shuffling phase, what he will be doing? He will be partitioning and grouping the cards. What is partitioning and grouping? All the diamonds will be grouped together. All the hearts will be grouped together. All the spades will be grouped together, and all the clubs will be grouped together. Similar is the case with all the 4 people. What they are doing, they are just grouping and partitioning the data. Now, the person who is actually doing the aggregation, he get this shuffled data, which is in the end he will be getting all 1 million records, which are grouped and partitioned based upon the suite. And this guy has to go through all 1 million records, and by the time he get all the clubs together, all the diamonds together, all the spades together, and all the hearts together. And then he has to just count all the clubs to give the count of clubs, all the spades to get the count of spades, all the hearts to get the count of hearts, and he has to add all the club, spade, heart, and diamond, and he has to add all those things, and finally he will give the results. It is very inefficient if you think when it comes to aggregation. If the 4 people who are actually shuffling the data, on top of it, if they also can actually add all the clubs they got, all the hearts they got, all the spades they got, all the diamonds they got, and they give the intermediate values which they get within themselves, and pass these intermediate values to the guy who is doing the aggregation, he now have to process lot lesser data compared to 1 million when the combining is not happening. So this concept of doing partial aggregation and generating intermediate values on the mapper output, on the mapper side as part of the shuffling part, is called as combiner. Okay, and ReduceByKey as well as aggregate_by_key uses combiner to generate those intermediate values, whereas GroupByKey does not. That's why for the 30 GB input data, GroupByKey is generating 10 GB worth of uh, uh, 10 GB worth of intermediate data on which aggregation is being performed, and finally the final output will be only 800 MB. So the input is 30 GB. After GroupByKey, it actually generates 10 GB worth of data, and then after applying that map function and get the size, the final output is only 800 MB. Whereas with ReduceByKey, for 30 GB of input data, you get 1 GB of intermediate data instead of 10 GB. So the amount of data that needs to be passed from the mappers, if you go to the DAG, okay, let me go to the DAG. Okay, let me take some other job which I have ran earlier. Okay, let me take this. And if you look at the DAG, this is shuffling. Okay, so if you use ReduceByKey as part of the shuffling, when it actually group and partition the data, it will also generate the intermediate values. Because of that, shuffle rate is only 1 GB. Whereas with GroupByKey function, the intermediate results are 10 GB. Okay, but the final output will be same. Okay, so the major difference between GroupByKey and the other two aggregate functions such as aggregate_by_key and ReduceByKey is the combiner. Okay, and from syntax perspective, I have shown the syntax to use GroupByKey. You have to write like this. First, you have to do GroupByKey, and then you have to apply the transformation to get the count. If it is ReduceByKey, we can directly get the count like this. Okay, so that is the syntactical difference between GroupByKey and ReduceByKey. Okay, now I'm launching Spark Shell again. So the major difference is combiner. And now we need to understand the difference between ReduceByKey and aggregate_by_key. So ReduceByKey uses the combiner, aggregate_by_key also uses combiner. Okay, so when it comes to combiner, there are two types of aggregations. One example is sum. So when it comes to sum of sums is sum of intermediate values which are generated by adding subset of values, and the sum of all the values individually will be same. It is called as transitive. Okay, so sum is a transitive function. So for all transitive functions, you can use ReduceByKey. There is average. Average of average need not be the average of the original values directly. Okay, what you have to do, you have to get the total sum and then total count, and you have to divide total sum with total count to get the average. Okay, just if you have intermediate averages, and if you try to use those intermediate averages and try to compute the final average, that will not be same as average of individual values. Average is not transitive, whereas sum is transitive. So for scenarios like sum, you can use ReduceByKey. For scenarios like average, where it does not follow transitive dependency, but still where it is not transitive, but still we can compute the intermediate results and then get the final results using slightly different formula. In those scenarios, we have to use aggregate by key. Okay, I will show an example later. We will start developing a lot more complex algorithm, and then we will revisit the syntax and also usage of all the three functions, and I will cover at that time. Now let us go back to the execution lifecycle again. So in this case, when I submit the original job, after making changes to the code by specifying number of tasks to be 8, especially on ReduceByKey, and when I ran it, the job is divided. It's a simple job. I'm just splitting each line into words and then counting those words. And this simple job actually, so this is the main page of the job. Okay. And then if you click on the job, it will show you the stages. The job is running in 2 stages. First stage, it is reading the data and computing the intermediate values of the key and the word, as well as one applying flat map in between. And it is using 270 tasks because we have 270 blocks for the input data. And then as we are using 8 as part of the shuffled RDD, it is using this 8 as the number, and it is creating 8 partitions to apply the reduce the functionality which is given in the ReduceByKey. On top of it, because we are using ReduceByKey, which uses combiner internally, on the map output also, as part of the shuffling phase, somewhere here, it will generate the intermediate values. That's why our shuffled write is only 1 GB, whereas the input is 30 GB. This 1 GB will be passed to this 8 tasks. Okay, so if you click on this, now I'm clicking on the second stage. You can see that it is using 8 executors. Even though I specified 32 executors, now it is only using 8 executors because 8 is less than 32. If I give 35 as number of reducer tasks, then it will still use 32 executors.
Code. This code can be modified to use the key.
Yeah, that's what I'm saying. Here, the tasks which are passed as part of the ReduceByKey is 8, which is less than number of executors. If it is 35 or 36 or 40, something like that, there will be 32 executors. Okay. Always it will choose the lesser number of the tasks which we are passing and the number of executors which are passed while submitting the program. Okay. And if you see the input size which it is processing, it's approximately 112 MB. And then on top of it, it is called as shuffle read. It's not regular read. It is, so this is the read size. It's approximately 128 MB, and this is the output. So that's why if you go back here, the output size is 898.7 MB. Okay, so overall input size is 30 GB, output size is 900 MB. The intermediate size is only 1 GB because we are using ReduceByKey, which uses combiner. If it is GroupByKey, if it works, the input and output will not change, but the shuffle write and shuffle read will be very high. Okay, and the shuffle read and shuffle write happens over the network. The lesser it is, the program will run more efficiently. Okay, and finally we are writing it to the file, and if we click on this, okay, and okay, it is not giving much of details here. And now if I go back, okay, I have ran this program and gave the location as this path, user D Gadi Raju, port count 99, I guess. And if you see here, it have actually generated 8 files. Okay, why 8? Always the number of files will be equivalent to number of tasks which are executed in the stage which have invoked this save as text file. So the stage which have invoked save as text file, we have hard coded the number of tasks to 8, hence it has created 8 files. And the naming convention is it always starts with part hyphen and then 5 zeros, and then it will increment up to 5 nines. I think after 99,999 it might fail. I'm not 100% sure. But the main thing you need to understand is this number of files is due to this value as part of the ReduceByKey. Okay, so everything are correlated. So you should run the program and you can play with these parameters if you want, and then you can see how it is performing. So now I will give 15 minutes time. You run the jar file, but don't run the jar file on the 30 GB data. Okay, run only on probably, let me see. So this is the input path, Hadoop ss-ls public random text title. First I will validate and then I will give the command to you. Okay, so here what I will do is, okay, let me do this. Part -m. I'm trying to test whether the patterns will work. If it works, we will try to use this. Okay, it is not working. Okay. Directory already exists. Number of executors, don't use 32. Use something like 8. I will give the command once I validate this. So on YouTube live session, Kashyap have asked what does yarn mode means. I will cover that little bit later. Okay, so yarn is the execution framework which is popular in the Hadoop world, and I will explain the yarn mode little bit later. Okay, so this one is working. So you use this command. You need to make few changes. So in this case, it out of these 30 files, it will only run against the files which ends with 9, 3 zeros and then *9. So it will be this one, and this one. So we are trying to process only 3 GB worth of data. Okay, so you can don't change the input path, leave it like that. You can play with number of executors. Instead of 8, you can give 2, you can give 16, but don't go beyond 16. Even beyond 8, don't go too many times. Once or twice, it is fine. And then you have to change the output path. Okay, so I'm giving this command to you. And now you can try. I will give 15 minutes time. You play with it. And if you have any questions when you run, let me know. I will try to clarify. If there are too many folks running at the same time, some of them will be in queue. You have to be patient. To monitor, you can go to this URL and see whether they are running as expected or not. As of now, there is only one job running, that is by Wiki. Okay. So I will give time till 12, 15 minutes more. Make sure you run and also observe and try to understand what is DAG, what is executor, what are tasks, how much data is being led by each task, how much data it is generated as part of the stuffing phase. All these things are very, very, very important.
So you should use our voice ID, right? Not yours.
Yes,
But
you have to use your OS ID. Yeah, you can ignore Wiki because if you go to Ambari, you can see we have both Spark and Spark 2. So it is just saying which version it is being used. So if you want to use 2 and if you want to explore Spark 2, which is not generally available, most of the distributions are still using 1.6.2 or 1.6.3. If you want to explore the latest version, you have to set the Spark major version to 2, and then it will pick up the Spark 2 automatically. And Spark yarn driver memory overhead is set but does not apply in client mode because we are using master yarn and then yarn client as part of our application. It will throw this warning, but you don't need to worry about it. I am also not 100% sure about this, what it is trying to convey. I will try to dig and I will try to come back about it later. Madhav, you have to tell explicitly. Again, you are pinging privately, so you have to tell explicitly what is the issue. Then I can tell. If, by that statement, I cannot help you. I am unable to run. If you can tell what is the issue, I will try to figure out. If you want, I can make you presenter and see what the issue is. Okay, there is a question from Vicky. Number of executors are same as number of partitions, right, sir? So if it is as part of the stage 2, where the reduce by key and save as text file is running, the formula is the number of executors will be lesser of the number of tasks or number of partitions which you have passed, and the number of executors which you have passed as part of the program. Okay, because in this case I have hard coded to 8, even though number of executors is 32 while submitting the program, it is using 8 as number of tasks. See, this is the problem. I actually pasted the command also. Okay, you are creating too many typos. There should be hyphen hyphen before class. There should be hyphen hyphen before master. There should be hyphen hyphen before num executors, and then only it will work. So you have to be a little bit more diligent. Here I pasted, and if you, I'm pasting again in the chart. Okay, there are hyphens in between. Okay, so try it out. That is the issue. You just have to fix the syntax. Okay, so I have changed. I have become the presenter now, and I'll be sharing the screen. On top, so Abhishek is asking the question. Let me. No, I got it. So Abhishek is asking the question, what is this and what is this? This is at the higher level, which is at executor level, and this is the individual task level. Okay, so executors are nothing but web services which will be monitoring the tasks submitted by it. You can see this executor have ran 3 tasks. This executor have run 3 tasks. This executor have run 5 tasks, and those details will be given here.
ఎగ్జిక్యూటివ్కి ఎన్ని టాస్క్ ఇవ్వాలని మనం డిఫైన్ చేస్తున్నాం. ర్యాండమ్గా
depending.
Okay, so if you see this wn03.itversity and if you sort by executor ID here, okay, see here, this one wn03 actually created 5 tasks and those 5 tasks details are here. So this is higher level report, this is lower level report.
where are we defining this task to each executor?
We can't control that. It will determine depending upon some algorithm. Yeah, that is not the error. It's just 2 warnings. That's fine. As long as after a while you will see the progress bar. It will hang for some time, and after a while you will see the progress bar Madhav. This is just information because even Vicky have asked the same question earlier, and I have explained. As we have 2 versions of Spark, by default it is picking Spark 1, and always when you actually look at the logs, you need not worry about info, warning, and error. Okay, you have to see those messages with a different priority. If you see info, you can scan through it and you can ignore most of the time. Warning, you have to understand what kind of warnings you are getting. But if you get error or exception, you have to focus on that. And whenever logging happens, for all the important logs, it will either use info, error, info, warning, or error or exception. So as long as you don't get errors or exceptions, you are good to go. Okay, whenever there are errors or exceptions, then you have to tell there is an error. Here you said got error. These are not errors at all. So observation is very, very important. I think you are a fresher or lesser experienced person. Observation is very, very important, and you should know the industry standards. Industry standards are for all the informational logs, it uses info. For all the errors or exceptions, it will use typically error. For all the warnings, it will use warning. Okay, so you have to segregate those things and you have to give different priority, and you should be very careful while using these terms. Okay, you should not say that you got an error in this case.
There are different types of
4 more minutes. Yes.
we are saying on the console application types, one is Spark and one is mapping types. What the difference?
So
when we are executing it,
if you run Spark jobs, it will application type will be Spark. If you run MapReduce job, it will application type will be MapReduce. If you run high queries in TES or pig high queries or pig scripts in TES context, application type will be TES. I will explain. You need to understand yarn and then what is the what are MapReduce framework, TES framework, and Spark framework, and how they are integrated with yarn. Then you will be able to understand this. For Spark, you just have to focus on application type Spark. If you are running through Spark shell, you will see Spark shell. If you are running a jar file, I think it will show a Spark application or something. Okay, 3 more minutes. So I'm trying to monitor to confirm who all have ran this script. So Digambar is asking, what should I do for class not found error? So typically, if you see class not found error, mostly there are only two scenarios where it will happen. Okay, and first of all, you need to identify whether this class not found is your class or third-party class. Okay, so in both the cases, there will be only two scenarios. Especially if it is your class, which is on which it is failing class not found error. Most likely it will be either typo, or when you run SBT package or any package command like Raghav also faced the issue. Sometimes you might have to clean and rebuild. Sometimes the compilation might not be completed, and the jar file which is generated might not have the classes which you are trying to run. Either it could, mostly it will be typo. If you give typo, if there's no class matching that name, you will get class not found error. And then when it comes to third party, it's not because of typo, because some of the dependency it might be trying to invoke some other class. And if it is giving class not found error, that means one of the jar file which is required to invoke your application is not available. And you have to make sure it is available when you submit the job. And we will see how to take care of that probably later today or sometime next week. Okay, so here you are saying this class is not in my directory. I know this jar file I am executing in lab. I know I don't have the jar with me. Can you please tell me path to copy the jar from? No, Madhav. This is different thing here. Digambar is asking. Okay. So when it comes to, so I think this is not related to what I am covering right now, work on program. It could be for Kafka or some other thing where it requires third-party jar files to execute the program. In that scenario, either you can download from online and copy to your location and give the path using jars, or you can actually run this command. Whatever jar file, if you know the jar file, you can say find user HPP, and this is the base location for the distribution we have, and then you can say name, and then give the name of the jar file. Let's say you want to have Spark Kafka.jar, means jar file which have the dependency between Spark and Kafka, and hit enter, and then you can give this path as part of jars if this is the one which you are looking for. Or first you need to know the version. So any jar file, it has three aspects to it: group ID, which is org.apache.spark, and then artifact ID. So this is the artifact ID, and then the version. Using this information, you can go to MVN repository. Okay, and search for the jar file. So in this case, if you want this one, if you know the jar file name, you can just search for it and hit enter. And then which one we are talking about? Spark Streaming Kafka. Click on this link. Choose the appropriate version of Spark here. 1.6.2 is the Spark version. Click on this, and then you can download the jar file. Okay. Let me try this copy link address. You can right click, go to copy link address, and then try this wget and paste that URL, and then you will have the jar file in your home directory, and then you can pass this as part of the Spark submit command. You just have to use jars, give all the necessary jar files which are not typically available on the cluster, so that when you actually run the Spark submit command, the jar file is also copied as part of the execution lifecycle. Okay. That being said, let me recollect what have happened very quickly, and then we will move on to the next use case. So I have ran this command called Spark submit. Okay, this is the command which you guys also have ran. So if you go to Spark official documentation, okay, and then submitting application, there should be a quick start. Somewhere there should be one picture. Let me take some time and try to identify that picture. I think cluster mode. Okay, so you are okay. I think okay. Then I thought something else. Madhav was right actually. I thought here your question was misleading, Digambar. You asked me what should I do for class not found error. You should have asked me that you don't have the jar file. Okay, what I have explained is in general, if you get the class not found error, what needs to be done. Okay, anyway, that's fine. But anyway, it was a good question in general also. For others, it might be useful. No need to be sorry. So now this is the cluster mode overview. Okay, what we are doing. So from the node, or in this case, the gateway node, we are submitting the program. And whatever is happening when we do the Spark submit, it is called as driver program. Whatever program we are submitting is nothing but a driver program, and it has to create a Spark context. And this Spark context have access to the executors. Okay. So here they use the term worker node. So the meaning of worker node changes depending upon the execution mode we are running. In this case, we are running on yarn mode. So if you go to hosts here, we have 3 worker nodes in our cluster. So I'm in the Ambari. Okay, I think Ambari, okay, not down, it's fine. We have W101, W102, and W103. There are 3 worker nodes in the cluster. So if you relate this picture with the host in Ambari, we have 3 worker nodes. And when we actually run the program without passing the number of executors, it is only creating 2 executors by default. And those 2 executors will go on to the worker nodes. Even if we give 8, for example, let's take this example of Abhishek's. So here, I think he used 10 executors, okay? And because he tried to process 3 GB worth of data, it has created 27 tasks, okay? But executors are 10. And if you see, all the executor addresses starts with WN, which is nothing but worker nodes on our cluster, okay? So here, if you go back here, like this, there are 10 worker nodes, okay? And each one will have cache. What this cache is for, wherever the executor is created, in that, within the 1 GB memory, because executor default memory is 1 GB, in that 1 GB memory, whatever jar file we are trying to submit, along with the third-party dependencies, if we define any third-party dependencies, all those things will go to the cache of the executor. Okay, so for all the executors, we'll have the cache, and this cache will have the jar file. Okay, and then to process the data, in this case, we need 27 tasks to process the data. And that means each one will approximately invoke 3 tasks. You can see it here. Some of them are 2, most of them are 3. And those are these things. So in this case, each task is running in serial mode. Within the executor, each task, the 3 or 2 tasks that are being executed by that executor will be running in sequential, because we have lesser resources for each executor. Okay. When this task is being performed, whatever data it has to retrieve, it will retrieve that data and apply the processing. What is that processing? Flat map and map function. Okay. That is how it will try to execute the data. So what is happening? The code which is submitted on the driver program is copied to the executors as part of the cache. And then if you use higher number of executors rather than 2, typically those executors will be distributed on multiple nodes in the cluster, on all the nodes in the cluster. And it will try to first fetch data local to that node. Okay, so in this case, he is trying to process 3 GB worth of data. The first priority for this task to process the data local to that node. If the data is not available on that node, it will do the network I/O, but it will limit the network I/O as much as possible. You get the data as part of the task, you have the code as part of the cache, and then the logic which is part of this jar file that is part of the cache will be applied on the data to process the data. Okay, and then it will get to the second stage, and it will use as many executors as it requires, and each executor will execute as many tasks as it will require, and then finally output is being stored to HDFS. Okay, so it starts from here and then go to here, and then finally go to the file system. And as part of the file system, depending upon the number of tasks which you are trying to use in the final stage, where you are trying to save as text file or whatever file format it is, those many files will be created. Okay. So that being said, for the next 50 minutes, I will try to cover yarn, because yarn is the execution framework, and you should know few important concepts here. Okay. So now, what is yarn? Yarn is nothing but a resource management framework. Okay, it will try to manage the resources in the cluster. Okay, so if you go to Ambari, HDFS is primarily for the file system. Yarn is for the resource management. MapReduce, Tez, Spark are the execution frameworks. Okay, so first let us understand the Yarn architecture. Yarn have master called resource manager, and all the worker nodes will have a daemon process called node manager running on it. Okay, resource manager is the master for the cluster, and node managers are the slaves. Okay, so if you go back to this picture, which talks about cluster mode, Spark can be run in different cluster modes. Okay, you can go to this. I think it is under overview. If you go to overview, this is the home page for the Spark documentation. If you go to overview and if you scroll down, there is a section called launching on a cluster, and then if you click on cluster mode overview, there are multiple cluster modes. One is standalone, other one is Apache Mesos, and the other one is Yarn. For production clusters, we never use standalone. We either use Mesos or Yarn. Okay.
That is standalone.
No, that is local. Local is different. Local is not cluster mode. Local standalone means you can have a Spark server. Okay. Yeah. So if you want to do it in local, what you have to do is So you have to go to the location where you have set up Spark, and then there will be two directories in it. One is sbin and second one is bin. If you go to sbin and see the files, there is startmaster.sh, I guess. Let me see. If you go back here, standalone deploy mode, you have to run this command startmaster.sh, and then
So we are launching one separate master.
no, we are not launching anything. We are not launching masters or slaves. We are using YAR.
No. In standalone mode, we are launching this master and slave.
Yeah, so that's native Spark standalone mode. It is only used for development purposes. Okay, so this is what you need to do anyway. But in production, we don't use standalone. We either use Mesos or YAR. Okay, so depending upon the cluster mode, these terms change. Cluster manager and worker node terms change. If it is Mesos, we use Mesos terminology. If you are using YAR, this cluster manager is resource manager. This worker node is node manager. Okay. So now going back to coming back to YAR, we have three node managers, and what these node managers do, they will consistently monitor the usage of resources on each of those worker nodes, and they will send the information to resource manager every minute, every second actually. It is called as heartbeat. So node managers will be doing heartbeat to resource manager to confirm that they are alive, and also they will communicate the resources being used on each of those worker nodes to the resource manager. Hence, resource manager understands the status of the worker nodes, how busy they are, and when the job is submitted, it will determine or it will try to figure out where the executors should be created by allocating the resources that are required to run those executors, depending upon the defaults or the custom values which we pass. Okay, so that is how the resource manager and node manager work together. Node managers manage the resources at each at each node level and communicate the details to the resource manager. Resource manager consolidate this information and try to maintain the status of the cluster from the processing perspective. Okay.
1%. When do you use the word data node? When do you use the word worker node? Or you can use.
So worker node is more generic. Okay. Worker node or slave node are more generic. They are the ones which will be doing the processing or storing the data. On the worker node, if you have the HDFS component, you can say that data node is running on worker node. Typically, on all worker nodes, we will set up the data node. In some cases, some exceptions, for example, if you try to set up EMR, AWS EMR, which is Amazon Web Services Elastic MapReduce, there will be a scenario where some of the worker nodes will be used to store the data, which means the data node will be running on that. But on the fly, you can increase the number of worker nodes with just node managers on that. So you can give a lot more horsepower to the existing data on the fly, and it is typical in cloud environment, where if you need more horsepower to process the data temporarily, you can increase the number of worker nodes just with node managers without data nodes and process the data, and then you can terminate those
Data
nodes.
node is just a subset of worker node, not complete.
Not really. In most of the cases, all the worker nodes will have data nodes, but there are exceptions. It's all software process. You can configure the way you want. You don't use the terms such as subset and all those things. It can mislead. Okay. These are all software process. You can set up the way you want. Okay. Anyway, so resource manager is the master and node managers are the slaves, which will actually invoke the executors from the Spark perspective. Now, to understand the resources used by YARN. So if you look at this report, right, it is saying memory utilization, CPU utilization, container failures, blah, blah, blah. And also if you click on this Ambari, you can also see how the cluster is performing. Okay, CPU usage, cluster load, yarn memory, etc. Node managers live, all these things. Okay. So there are certain settings. If you click on yarn and go to configs. Okay. So here we will tell how much memory yarn should use and how many CPUs yarn should use. So the memory is 24 GB in this case, and number of cores is 6. Okay. So I'm trying to use 24 GB RAM and 6 cores on each node. So now resource manager have, so when it comes to yarn, the two main components are resource managers and node managers. Resource manager is master, and resource manager have a web interface where you can actually get the details about the resource manager. Here you see total memory for yarn is 72 GB, and total number of vcores is 18. From where these values came into picture? It's from these configurations. If you go to yarn and go to configs, and you see 24 GB RAM on each node and 6 cores on each node. As we have 3 times 24 is 72, 3 times 6 is 18. So this is the cluster capacity from memory and vcores perspective. And then out of the node level, there are some container level settings. So container is a generic term. Depending upon the type of application, if you go here, application type is MapReduce. Saurabh, someone who is a lab subscriber, have ran a MapReduce program. And for others, what we have ran earlier are all Spark, right? So if it is Spark, in the Spark context, container means executor. In the MapReduce context, container means either a map task or a reduce task. Don't worry too much about what is map task, what is reduce task. You don't need to worry about it. But what you need to understand is, depending upon the context or the underlying technology which is being running under yarn, the meaning of container can change. If it is Spark, as we are talking about Spark, container is nothing but executor. So here, for each executor, what we are saying is we can use memory within this range, 1 GB to 4 GB, and vcores between 1 and 6. Okay. For each executor, we cannot go above 4 GB and above 6 GB. Similarly, we cannot go less than 1 GB and less than 1 core. Okay, so when it comes to Spark, the container means executor. Okay, and
So
now
this container memory is executor memory, that is 1 GB.
so this is the range which we can specify. So yarn only set the it's kind of a cap or define the ranges. So overall memory on each node, yarn will only use 24 GB. So let's say you was submitting few MapReduce jobs, few test jobs, and few Spark jobs. All these things has to use memory within 24 GB. It cannot go beyond 24 GB. That's the meaning of this one. And when it comes to container, containers are the ones which will actually process the data. When it comes to Spark, they are executors. When it comes to MapReduce, they are map tasks or reduce tasks. When it is test, they are called as test containers. So depending upon the technology, the context change, and at each plugin or at each technology which we are trying to plug into the yarn, we have to specify the memory settings, and these are the ranges which we should use. Okay, so these are all logical settings, nothing physical here. We are telling that okay, we have to use these values to set certain memory settings and CPU settings. Now if you go to MapReduce, okay, MapReduce is we are trying to plug into the we are using we have integrated MapReduce to YARN. You can see that map memory is 1.5 GB and reduce memory is 2 GB. Similarly, app master, which is the master which will control the life cycle of the job, we have specified 1 GB. All these settings should fall within the range of the container, 1 GB to 4 GB. You cannot go below 1 GB or beyond 4 GB. Similarly, if you go to Spark, we are using default values, and the default values you can go to Spark env, and you can see number of instances is 2. We don't need to worry too much about it, but these are the two things which actually control the memory settings. The container settings or executor when it comes to Spark. We are trying to use 1 as executor core and 1 GB as Spark executor memory.
How many cores can we give it the maximum
That's what
for a Spark job? So it should fall in that YARN kind.
in YARN there are two settings. One is memory, other one is cores.
So
6.
not more
Okay,
than 6.
so and this 1 to this 6 again, how many containers we can create depends upon the number of virtual cores which we have configured at the YARN node manager level. Okay, here we are giving only 6 cores on each node. So if you give 6 cores for each container, you can only, for each executor, we can only execute 1 executor per node. But if we give only one vCore for each executor, we can, because number of virtual cores is 6 here, we can run 6 executors on each node. If we give 2, because number of virtual cores is capped at 6, we can give 3 executors per node. As it is 3 executors per node, and as we have 3 nodes, we can go up to 9. Even if you go above, it will not error out, but the resources will not be used effectively. It will be context switching between sleep and active, and there will be your CPU overhead can go beyond 100%, and the performance of the cluster can go. There could be contention on the cluster. So now, I hope it is clear about the settings, and now let us understand what will happen when we run a job in YARN mode. I'm running the same job again. Okay, so when I run, while it is running, what is happening? You can see there is something called application master here, and if you click on this application master, okay, not this one actually. If you click on this URL, you can see this application master is also running on one of the worker nodes. What is this application master? Application master is the one which will maintain the life cycle of your job. Okay, so even though our capacity is 18, let's say our capacity is 18, even though our capacity is 18, we cannot give 18 executors, because one container has to be given to the application master, and then 17 executors can run effectively on that, given the memory and everything are in line with our settings. Okay, so this application master maintains the life cycle of your job. That's why you are seeing application master URL here. Okay, as long as it is running, it will use the application master URL. Once it is done, once the execution is done, now the execution is done. Let me refresh this one. Once the execution is done, it will change it to history. So if you go back to Ambari and if you click on Spark, there is a component called Spark History Server. What is this Spark History Server? As long as job is running, there is a web service running um, uh, as application master. As long as application web server is running, there will be a port associated with it, and you can talk with it and get the necessary details about the job. But once the job is done, the application master will also be killed. It will not be available. To make it available beyond the scope of the execution of the job, Yarn have concept of history server. If it is MapReduce, there will be MapReduce history server, and if it is Spark, there will be Spark history server. Okay, and using that Spark history server, you can access, you can still access the logs. So automatically it will redirect. Even if you start with application master URL, once the job is completed, except for the brief period while it is cleaning up and copying the necessary logs into HDFS and make them available to job history, except for a few seconds, the logs will be accessible as long as we are maintaining the history in HDFS. And here you can click on the history. Now you can see that it has gone to a URL called history. Now let me run it again, and then you will understand. Okay, I'm running this job, in this case with a little bit more data. I'm trying to process 10 GB data, and let me run this. Okay, now it started. Click on application master. Okay, you see it is going to something called proxy application blah blah blah. So proxy is actually hiding the complexity of from where we are getting this URL. The actual location where application master is running, you can click on this link, and this is the node on which it is running. Okay, but proxy will hide the complexity of getting the details about from where the logs are being rendered. And if you click on application,
any of the worker nodes, it's
yeah, it depends upon the load on the cluster. Okay, so the point Abhishek is making is application master will be created on one of the worker nodes. Depending upon the load, the resource manager will determine where the application master should be invoked, and application master is the one which will control the monitor the life cycle of the job. Okay, and here, as long as it is active, as long as the job is running, you will see the link like this. This is the resource manager URL, and then the proxy, and then application ID. Okay, you can also get the details by running yarn application list, and here you can I think this will give yeah, this is the tracking URL. You can use this to track. Okay, and also you can get the application ID here. Okay, so now the job is done, and see automatically it has changed to history server. It will be automatically redirected. Okay, and then you can go through the job and you can see the DAG and all those things. Okay, so this is about Yarn. Yarn can run Spark, Tez, and MapReduce. When we say MapReduce, all MapReduce based tools such as Hive, Pig, Scoop, all these things runs under MapReduce. And Yarn can understand all these tools and allocate the resources effectively. Okay, now we will do an exercise. There is a concept called capacity scheduler, which you need to understand. As we are using Hortonworks cluster, it uses capacity scheduler, and we need to understand what it is. Okay, so what is, first let us understand what is scheduler. Scheduler is, let's say I'm trying to run this job again. or every one of us want to run this job again. Okay. And in this case, let's say there are 10 people. Okay, and everyone try to use 8. What is the capacity of our cluster? 18, because each one can go up to 6. But each one of us is trying to submit 8 executors at a given point in time. If there are 10 people, we need 80 tasks. When there are multiple jobs that are being running, instead of filtering out, the framework, which is Yarn in this case, should be smart enough to schedule and give the resources as uniform as possible to all the folks who are trying to run the job at a given point in time on the cluster. And that process of allocating the resources effectively for all the jobs that have to be run on the cluster over a period of time is called as scheduling. There are 3 types of schedulers. One is FIFO scheduler, which is default in general, but we should not use FIFO. Okay. Then there are primarily two types of schedulers. One is phase scheduler and second one is capacity scheduler. Okay. So when it comes to Cloudera distribution, phase scheduler is default. And when it comes to Hotnode's distribution, capacity scheduler is default. Okay, so phase scheduler is primarily pushed by Cloudera and capacity scheduler is pushed by Hotnodes. First, let us understand what is FIFO scheduler. So I will try to submit 2 jobs here. Okay, and for that I am opening 2 windows. And I'm trying to run with 32 here. So capacity scheduler is just improvisation on the FIFO. So we can, even though my cluster is currently running on capacity scheduler, I can easily explain in the context of FIFO scheduler. Okay, let me use 89 here. So I'm submitting my first job, which uses 32 executors. Okay, and you guys don't run anything right now. I have to go to the resource manager UI. And the job is started. You see, even though I gave 32, it is only running 19 containers at this time. Okay, now it is 33. The reason, okay, running containers is 33. No, it was not running. Anyway, let it run. Right now it is running with 33 containers. Now I will submit to one more job. So now 2 jobs are running. Ideally, it should not run more than 18. I think there is some issue which I need to figure out. So right now, it is still initializing my second job. It is not even getting the resources. Okay. Yeah, now okay, here it is running with 33 and this one is running with 3. Okay. And I'm opening another window. Okay, let me use 85 here. Now 3 jobs are running.
Come back.
First one got finished. No, it errored out. Yeah, it errored out. Okay, so these are actually erroring out. Now it is running. Okay, so let us see. I think now one job is completed. So if you see here, this is the first job which is completed. This is the second job which is running right now. And this is the third job. You can see that it is not even progressing. Okay. The reason it is not progressing because it is running in the FIFO mode. Whatever submitted first, until it is completed, the next job will not get any resources. Okay. In this case, now it started getting resources because there. Okay. Let us see. Yeah, this job is also completed, even though it failed in between temporarily, but the job is completed. Until when I submit the third job, first job is just completed and second job kicked in. Okay, until the second job is completely done. Once it saturates the capacity, I think capacity is 36. The maximum capacity is 36. I have to figure out why it is using 36. I thought it will be 18, but it is 36. Until it reaches that 36, okay, it is giving the resources to the job. But once it reaches 36 threshold, it is queuing up all the remaining jobs. Okay, let me run it again. Okay, probably by now everything should be done. Once this is also done, I will explain again. Now I will give more resources to the first job itself. Instead of 32, I will try to give more than that. Just give me a moment, it is almost done. Okay, so now I'm running it again. We have 3 sessions. So instead of 32, let me give 64 in this case. Let's see what will happen. I'm giving the entire directory here, which is 30 GB worth of data. So we have given number of executors as 64, and let us see how much resources it will take. It's taking 36 containers. There is a lag. It is not showing the report immediately. So 35 for processing the data and 1 for the application master. Okay, now let me run the second one. So right now it is progressing. It is actually running 35 executors at a given point in time, and others are in queue. Now I am running the second job. Okay, here let me take it as 78, and let me run it with 32 itself. Okay, so now as long as the first job give up the resources after completing most part of it until the resources required by the first job is less than 36. The second one will only be in the accepted state. It will not get any resources. It will be in queue. Even though the first job, some of the tasks are being completed. Here, see, if you click on this one, now 81 are completed. Total it required 278, 82 are completed. So these are actually completing. So this is nothing but FIFO. So until the first one, the required resources for the first one is less than 36 as per our capacity, the second one will not get any resources. So this is what FIFO concept is. And Apache, yarn from Apache, the default scheduler is FIFO, but we should not use it in production. And then with Cloudera, the default is FAIR. So in case of FAIR scheduler, at this time, when the first job is being completed, when the resources are given for the other tasks, whatever is pending at that time will evenly get the resources. So in this case, if it was configured with FAIR scheduler, instead of second job being waiting until the first job's required resources is less than 36, the second job also will start getting resources. And at a point in time, if both are long-running jobs, both will have equal amount of resources. That is called as phase scheduler. At any point in time, all the running jobs at that particular time will get their fair share of resources. That's why it is called as phase scheduler. And to determine the current scheduler of the of our cluster, you can go to yarn and go to configs. And in this, you can search for capacity or scheduler. Okay, if you search for scheduler, you will know what type of scheduler you are using. So here it is confirming that we are actually using something called capacity scheduler. And the behavior is same as FIFO. Then what is the difference? So the difference between FIFO and capacity is capacity scheduler have the concept of queues. Okay. So in this case, let's say you have a production queue, you have a non-production queue. And at each queue level, you can allocate the resources. Let's say you want to give 80% of the resources to production queue and 20% to non-production. Out of this 80% resources, all the jobs that are submitted in that production queue will follow FIFO. First in, first out. In this case, we have only one queue, which is default queue. Hence, ours is kind of FIFO scheduler only. But in production, we typically have multiple queues. We will not leave it like this. Otherwise, what will happen? Some of the critical jobs which are smaller in nature will be waiting eternally. So within the production also, we can actually segregate multiple queues for larger jobs, smaller jobs, etc. And make sure the smaller jobs go into a separate queue wherein they don't need to wait until the long-running jobs are completed. So to understand more about capacity scheduler, again, you can search for ITversity, YouTube, scheduler. There are few videos, scheduler for you, FIFO, FAIR, capacity. I think in one of the video I have explained incorrectly with respect to capacity scheduler, but whatever I'm explaining right now is more correct. Okay, so here if you want to read some material, you can say Hortonworks capacity scheduler. Okay, and then you can click on this. And this is important. Setting up queues is the important concept, and this is how it will look like. We have the root queue, which is default, and then in that you can have parent queues such as support, engineering, marketing, etc. in this case. And then within each of them, you can have different sub queues, and you can assign jobs to those queues, and all these things have to add up to the 100% of the resources. So in this case, you can give 50% to support, 25% to engineering, and 25% to marketing. And out of that 50%, you can give 10% to training and 90% to services, 10% to development, 10% to QA, and 80% to production, something like that. So you can manage the queues and make sure that jobs run as effectively as possible. Okay. So now we will do an exercise. Sometimes if it is waiting for a very long time, it will fail. I think that is why this one failed. This one did not complete. So if you go back to this resource manager UI, because it did not get the resources for a very long time, I think it just failed. Yeah, there will be parameters which will control the time interval before it gives up. I think it is succeeded. Let us see. Yeah, it is succeeded. It is succeeded. It did not fail. Okay, we can validate. Okay, here it did not give the number. Yeah, we can validate on the output directory, and also probably somewhere it will give the details. Storage. Yeah, you can actually see the output directory here. Yeah, so this one is also successful. Actually, you can go to environment in this, and you can get all the information, all the environment variables for your job from here. So from here, we can say that this is the job which is completed for this path, and it is successful. Okay, so this is about yarn and the capacity scheduler which is configured on top of our cluster. So now I will give 10 minutes of time. You can run this job simultaneously with others and see how it is behaving, to make sure you also understand about capacity scheduler. And as part of the afternoon session, we will talk about some real world use case, and we will again go back to the development of new applications. Okay. So you all can run simultaneously and you can see the behavior. I didn't get your question. So Madhav have asked 2 questions. One is number of worker nodes equal to number of executors? No, it's not correct. Number of executors is configurable, and as I have mentioned to you, if you go to the yarn and if you go to the V course, ideally, as per my understanding, number of executors can go up to 18 at any point in time. You can give as many number of executors as you want, but only 18 can be active as per the configuration. But for some reason, it is multiplied by 2, and I'm getting 36. I need to figure out why it is taking 36. I was expecting it to be 18. Okay, so that is the answer for the first question. And the second question, for last Spark job, 7 containers and 7 vCores, how? Where it gives 7 containers? Okay. So if this is not, if you still have the question, Madhav, please rephrase, and I will try to respond to your question. So Vicky is saying one executor can have 1 GB of cache. If one worker node has multiple executors, how cache will allocate? So cache is not 1 GB. Okay, I will. Very good question here. So let me do this. Let me run this Spark submit command once again. Okay, and here on top of number of executors, let me give executor memory as 4 GB. Okay, executor memory is the one where we can override the memory that needs to be allocated for the executor. And now let me run this. Okay, I have to give 7. Some unique number. Let me give it a 68. And let me run this. So if you see, it is failing, saying that required executor memory 4 GB plus 384 MB. This 384 MB is the cache size for each executor. By again, there could be some parameter which is controlling this. So the cache it is taking 384 MB, and this cache is primarily to to have your jar files cached so that it can be applied on top of the data when the executor tasks are being processing the data. Okay, so here we have given executor memory as 4 GB and it requires 384 MB for caching, for the cache purpose for each executor. Because these two are exceeding our container memory, which is configured at the yarn level, it is failing. You can see yarn scheduler maximum allocation MB is being violated, and it is given for it is 4 GB in our case. So now if I run the same job with 3.5 GB, we cannot give decimals like 3.5 GB. Instead, we have to give something like 3072 and 512, 3584 and MB, and hit enter. Now I am giving 3.5 GB. Now it will run without any issues. Okay, so the whatever executor memory we are trying to pass plus whatever amount of memory it is using as cache should not exceed the settings which are configured at yarn container level. Okay, now if I go back here and if I go to the job, okay, I will complete the answer in a moment. This is only partial answer for your question. And if you click on environment, you can actually get the details as part of this is the memory which we are trying to use. Okay. Similarly, okay, Spark execute instances is the parameter which will. So whatever you are specifying as executor num executors, internal parameter is Spark execute instances, and this one is for executor memory. Okay. And now to answer your question. So you said one executor can have 1 GB of cache. If one worker node has multiple executors, how cache will allocate? So each executor is different. So what is the number of executors I have given? 8 executors. If all the 8 are active at a given point in time, how much memory it requires? Approximately 8 into 4, which is 32 GB. As long as the 32 GB is less than the available capacity on the cluster. What is the capacity of cluster from memory perspective? It is 72 GB. Okay, so as long as it falls under that, you are good to go. Each executor is isolated completely with respect to other. As long as the allocated memory and allocated cores are within the ranges defined as part of this page, you are good to go. Okay, now let's try one more thing. Now what I'm saying, 8 executors and approximately 4 GB memory. So it is using 32 GB capacity. Okay. What is it?
We can increase it.
Yeah. Now let us try to use, how much should I give? Let me give 24. Okay. And see what will happen. So here we are giving 24 executors and approximately 4 GB RAM, which is exceeding 72 GB, which is our total capacity of the cluster. And now let us see what will happen. So you can, once you run this, so you can experiment all these things, but don't experiment as part of the class. It will waste time. After class, you can experiment all these things. And if you have any questions, if you do not understand anything, you can immediately let me know. You can go to Ambari and see how the resources being allocated and all those things like CPU utilization, memory, etc. Okay, now let us see whether it is getting the resources or not. Most likely it should fail as per my understanding, but it is not failing. So let us see. Okay, so here you see it is only using 17 tasks. It is not using 32 or 24. Even though I gave 24, it is only using 17. So depending upon the available resources, it has created so many executors. Even though I gave 24, it has actually created only 17 executors to process the data. So if I go back to here, using wrong one. Okay, so running containers are only 18. And if you go here and click on this and click on this one, which is still running, you can see it is only 17 executors. 17 plus 1 for application master. 18 into 4, approximately 72 GB RAM. Okay, so even though you have given 24, because it cannot accommodate all the 24, it only use whatever it can accommodate within that. It did not throw any error. Okay, so this is how the yarn will maintain the resources. Is it clear, Vicky?
What about the number of cores? How to achieve best performance in this scenario? Only one core will be better. Plus, if you increase more also is.
So cores again, core requires both memory and amount of threads given to each executor. It's a little bit more complicated. Okay, so I will try to come up with some example later. I tried a little bit, but I could not understand it completely. For now, just focus on number of executors and executor memory. These two things we are clear. I might not be able to do it today, probably as part of the next class, or I will conduct one separate workshop on Spark performance tuning. By the time I will have everything ready and I will demonstrate all these things at the time. Okay, so that being said, now we'll break for lunch. We'll catch up at around 2 to 10. It depends upon how fast we will come back, but mostly it will be between 2 and 2:15. Okay, Vicky is asking, can you explain a bit -- master yarn local and -- master yarn cluster? No, there is only two things: -- master yarn or -- master local or -- master mesos. So these are three. So if we go back, yes, Digamba, this video will be available as part of the playlist. I will share the playlist with you. Okay, so this is the playlist. And okay, I have to answer the question by wiki. So Spark programming guide. If you go here again, go to this documentation and go to overview. Okay, as part of the overview, so there are different cluster modes and one local mode. The different cluster modes are standalone, mesos, and YAR. And if you don't have any cluster, then you have to run in local mode to validate. Okay. So because on our local PC, we don't have any Spark server running, we are running in local mode. Whereas on the cluster in production and all, we will either run in mesos or YAR. We will not use standalone. Standalone is again for testing and development purposes. So if you want to run in YAR mode, okay, you can click on this link. No, not this link. Actually, there should be an example. Yeah, you have to click on that link. So when it comes to yarn mode, you just have to say -- master yarn. Okay, then the program will be running in yarn mode. Okay, if you want to run in mesos, you can go back and go to mesos, and here, if you see the way you submit, you don't say -- master mesos. You have to give -- master, and you have to give the URL for the mesos master. Then the program will be running in the mesos mode. When it comes to yarn mode, you just have to say master as yarn, and then go to etc Hadoop const, sorry, not Hadoop, etc Spark const, or even we can use Ambari also to get the properties. And here, if you look into the Spark defaults.conf, okay, I think Spark env.sh. One of these files will have the integration point. Yeah, here you see the defaults are all yarn related stuff. Somewhere there should be integration with respect to yarn. I think grep yarn spark defaults.conf. Yeah. So here you can see the that Spark is already integrated with yarn. Okay, that's why it is. You don't need to explicitly specify what is your resource manager IP address and port number like you have to do it in Mesos. But you need to make sure that there are necessary parameters already configured in these two things. And when we use Ambari or Cloudera, it will be automatically taken care. You don't need to worry much about it. Okay. And the reason why it was complaining with respect to 384 MB earlier, when I give 4 GB, is because of this driver memory overhead and executor memory overhead is 384. I think this is the value which will drive the cache capacity. Okay, and that's why it was failing earlier. So when we run Spark submit command, it also launches a JVM, and that JVM also requires some memory. So driver is the one which is managing the Spark submit command. Okay, is it clear, Vicky, or do you still have question? Okay. Okay, then we'll break for lunch. It is 1:06 now. We'll catch up at 2:15. I will leave the WebEx session like this, but I will suspend the Hangout. And those who are following this morning session, I just placed the URL for the playlist. And if you go to that playlist, okay, I didn't place the playlist. If you go to that playlist, Okay, and this session is this one, day 2 session 4, and afternoon session will be day 3 session 5. You can just click on that and join it. Okay, this is already set up. I just have to start, and I will start once we are back from lunch. Probably it will be around 2:15. Okay, so try to be there by 2:10, 2:15, so that you don't miss anything. No, Madhav, it is not last session, but there is no session tomorrow. We will have one more session over next Saturday. I think it will also be a full day session because we are very behind. No, not performance
No,
tuning.
the performance tuning also we are covering. So
No, performance tuning I will cover later.
we are covering. At least we are touching.
Yeah. So there are some things which are not within the scope I am covering. And also there was one very important question as part of the YouTube chat. Someone is asking, Kirti is asking, I am new, is this topic related to CCA 175 certification? 70% to 80% yes, 20% I am covering some other important things related to Spark, which might not be very relevant with respect to the certification. Okay. And also one question from Kashyap, what happens if one of the tasks fail on a block of data piece? The task will be failed over to some other node. Or I think it will try to restart on the same node. The same task will try to be restarted on the same node. But if the executor fails, then the executor will fail over to some other node. So it could be task failure, or it could be executor failure also. Okay, if it is executor failure, all the tasks which are completed by that executor has to be redone, and it will be done on some other node. If it is just a task failure, the task will be restarted on the same executor. Okay, so that being said, let's catch up in the afternoon session. If you like this video, don't forget to click on the like button. And if you want to share with our friends, you can click on share and share with our friends. And again, if you want to practice and if you don't have environment, you can go to labs.itversity.com, choose the plan, one of these plans, and sign up for the lab, and then you can start practicing and you can ask questions whether you sign up for the lab or not. If you have any questions, go to discuss.itversity.com and you can start asking the questions, and we will try to answer your questions as quickly as possible. That being said, thank you. Bye.